everyone, welcome back to our class on polymers. I hope all of you are doing well. So in the previous lecture, we discussed polymers and introduced the concept of polymerization, isn't it? So we learned that polymers are high molecular weight macromolecules formed by repeated joining molecules like which is known as monomers and all. So, and in that classification also we just understood the polymerization. What is meant by polymerization, or like what are the different types of polymerization happening and all. So in today's lecture, we'll continue from like where we stopped. That is, we'll continue with what is meant by polymerization as well as what are the different types of polymerization, and briefly on how this polymerization or what is the mechanism of particularly addition polymerization happening. So let us begin with the first topic of today's lecture, that is types of polymerization. So as we knew, there are two types of polymerization, or we can say polymerization can be broadly classified into two major types. One is addition polymerization and the other one is condensation polymerization. Now, although like both the process produce polymers, they differ significantly in the way monomer molecules combine with each other. Okay, so the classification is based on the reaction mechanism involved during the formation of a polymer chain. So let us see one by one. What is addition polymerization? So in addition polymerization, what happens? Monomer join together without the elimination of any small or single molecules. Okay. Whereas in case of condensation, what happens? It will be like monomers will be joined, but there will be a small elimination of the molecule. A small byproduct will be removed, such as like water, ammonia, or like hydrogen, like HCl or anything. Okay. So let us see. Now, if you see this example, we can see it is like ethylene molecule is there, right? C double bond C, H and H. So, CH2 double bond CH2, which is known as ethylene. So, how it is getting as polyethylene? So, what is happening? This polyethylene, like ethylene is getting added up. So, what is happening normally? C double bond C, where what will happen? C single bond C, it will form as C. Addition of the monomers is getting happening. Okay, there is no removal of any byproduct. So, this is known as addition polymerization. So the addition polymerization is normally instigated by the application of, how this will happen? It will happen by the application of heat, light, pressure, or any catalyst. Yes, because to break down this bond, double bond, it takes a lot of energy. So breaking down of this bond is not so easy process. It takes a lot of energy. So we need an extra stimuli or like external stimuli like heat, light, or pressure, or even a catalyst. A superb catalyst can help in the breaking down of this material. So this is all about addition polymerization. Now when it is pressure, it doesn't mean that pressure can be a low pressure at all. It should be high pressure. Heat and light also in the same way. It should be giving a high amount of heat, and light also should be there. Catalyst as we all knew, catalyst, it's like a small material or like a minute amount of material which will not take part in the reaction, but it will enhance the rate of reaction, right? So that is known as catalyst. So all this will be used to break down the material, and we'll get a polymer reactions. Addition of monomers by the application of heat, light, pressure, or catalyst, and when the double bonds or double covalent bonds are broken down of the monomer molecule and forms a new single bond, and this replica is known as addition polymerization. So now let us see about condensation polymerization. What is condensation polymerization? So condensation, as we told already, what is condensation? It is like adding up of monomer, but what will happen? It will remove a small amount of byproduct. That means in condensation polymerization, several bifunctional monomers, okay, they will react with one another through a series of condensation reaction. So one addition of monomers will be happening, and each molecule of byproduct will be removed off. This, unlike addition polymerization, what is happening here? The formation of each new bond is accompanied by the elimination of a small molecule. So these small molecules, like it may include like water, carbon dioxide, ammonia, or any other simple molecules, depending on the type of reaction involved. Okay, like not reaction, reactants involved in that. So this elimination of small molecules, what it shows, it is characteristic feature of a condensation polymerization. Okay, this is like condensation polymerization. So if you see this, we can see that hexamethylene diamine and adipic acid condense. So hexamethylene diamine and an adipic acid is there, which are condensing, like reacting together, and what we are getting? We are getting nylon 6,6. Yes, we are getting nylon 6,6. So this is nylon 6,6. So what is happening here when this thing's formed, right? Here, from here, like H2O, a small molecule of water molecule is removed off, and when this molecule comes again, from here another hexamethylene diamine will be there, no? So from here again H2O will be removed off. Like this, two molecules of water molecule is removed off. This is how hexamethylene diamine and adipic acid combines or condense to form a nylon 6,6 molecule. So condensation reaction or condensation polymerization is a polymerization technique where monomers react together with each other by the removal or elimination of simple molecules such as water, carbon dioxide, ammonia, etc. So now let us see each one. What are like the difference, main comparison, okay? How we can compare addition polymerization and condensation polymerization. This we can do only when we are thorough with the meaning or like definition of what is meant by addition polymerization and what is meant by the condensation polymerization. Yes. So let us see what is happening in the first point. The first point states that monomer must have either a double bond or triple bond, which is there in the addition polymerization. Yes. So until and unless if there is no double bond or triple bond, right, this cannot be broken and we will not be getting an adding up. This monomer cannot be added up. So a must requirement for the addition polymerization to happen is that it should have a double or triple bond. Whereas in case of condensation polymerization, what is there? It is like two dissimilar or like two similar or different functional groups. Yes, as we saw in nylon 6s in the previous slide, we saw that there is like alcohol, like amine group was there, right? NH2 was there and NH2OH was there, plus an carboxylic acid was there, COOH was there. So what was happening? OH from this and NH from this was getting removed off. Yes, as water molecule. So different functional group should be there. So this is how. So it can be two different functional group material or two different monomeric material. So when it is two different monomeric itself, functional groups will be different maximum. So that is the first point of differentiation. What is second one? It results in no byproduct. We saw addition means just adding up of the monomers, there are no byproducts. Whereas in case of condensation, there are removal of the byproducts such as ammonia, water or HCl. So in case of third difference, what is that? It results in the formation of the polymer. The addition of the monomer results in the formation of polymer, right? So here what is happening? Since the name is addition polymerization, addition is happening. In case of condensation, it is condensation reaction happening between two different monomers. Yes. So one is addition and one is just condensation. What about the fourth point? We can say that since in the addition there is no removal of byproduct, so how much ever monomer is getting added up, same will be the number. Yes, the polymer chain will be of the same number. So what will happen? It is like a multiple of monomers molecular weight. Whereas in case of condensation, what will happen? Since a small element like molecule is getting removed off, it will never be a same multiple. It cannot be a same multiple, right? It will be either less in the molecular weight. So that is the thing with the condensation polymerization. In addition polymerization, the molecular weight will be same of that of what? Monomers. But in case of condensation, it will not be the multiple. It will not be the multiple. Whereas in addition, it will be the multiple of monomers molecular weight. So in addition polymerization, we told that the bonds cannot be broken, right? So what we need? We need an initiator. Yes, when we need an initiator, what is there? We can either use Lewis acids or base or any other catalyst to act as an initiator. Whereas in case of condensation, what will happen? There are like different molecules using as catalyst can be used as a condensation polymerization. Now, few examples when we talk, we can say that normally used PVC, polyethylene or like Teflon, these all are like good examples for the addition polymerization. Whereas bakelite, which we use for the switchboards or like telephone gadgets or like any other hard materials, right? Or else silicon, epoxy resin, all these are like examples for condensation, polymerization. I hope this part, comparison between the addition polymerization and the condensation polymerization, is very clear for you people. And if it is clear, now let us move to the next topic, that is mechanism of addition polymerization. Yes, mechanism of addition polymerization. So why we are concentrating maximum on addition polymerization? Because it is like multiple, right? And it gives us like thermoplastic material also. Yes, so which can be reused. So that is why more enhancing or like more enhancement is there for the addition polymerization. Now let us see mechanism. We told that addition polymerization happens by the addition of monomer material. So it can happen in three different ways. One can be cationic addition, okay, or else like anionic, or else we can have a free radical. Okay, free radical. So three ways this mechanism can happen. That depends on the material, like reaction, whatever we are focusing. So three different ways we are happening. So now for this class, I will more suggest or like more stress only on the free radical mechanism. Yes, free radical mechanism. Now what is happening in the free radical? What do you mean by a free radical, right? A radical which is like free and highly reactive. So it needs a material that has to be removed, like reacted very fast. Yes, so let us see free radical. So how this is happening? A free radical, like when we say that it is an atom or a molecule which will contain an unpaired electron, obviously. So this electrons, know what will happen? They are like highly stable, and wherever they exist in pairs, like they are highly stable when they exist in pairs, like but when they are unpaired, then it will be highly reactive. So how it will be reactive? They needs one more adding. So one is like when two are there, it is like highly stable. So one is broken down and only one is material. So what will happen? This will always have the tendency that it has to get some more to get it stable. Otherwise the stability is not there. So it will always have the tendency to get it more stable one. So it will like fixed for the getting up, okay, to get some or the other material from us. So what is happening here? Now this reaction, when we talk on free radical polymerization, this usually happens in three different stages. So what are there? The main thing is like initiation, second one is propagation, third is termination. So what do you mean by initiation? Initiation is like where the reaction begins. What about propagation? It is like where the polymer chain continues to grow, right? It's like moving on, how the reaction is moving on. Third is termination. What termination? As we tell, no, terminate. It is like end or stop. So where the reaction has to stop. So the main three stages of a radical polymerization is initiation, propagation and termination, right? So now, before like we move to the polymerization reaction, we told that we need a free radical, or the name itself is free radical polymerization. We need a free radical. Now where will we get this free radical? Yes, how it has to be generated? So the normally used free radicals are like hydrogen peroxide or like benzoyl peroxide. Yes, H2O2 or like BPO. These are the normally benzoyl material is like highly reactive. So this will be the maximum used free radical for the like reaction. So like this peroxide compounds, what it has having? It is having a relatively weak oxygen-oxygen bonds. So what will happen? Oxygen-oxygen bond is like weak. So what it happens? To break this, it is very easy. Once it is broken, then it will be a free radical, right? O free radical and then another O free radical. So what we'll get? This O free radical can be used as a, and where it can be used, this can use or this can attack easily the C double bond C. Yes, it can attack C double bond C. Now what will happen when it is attacking? This bond again breaks and it will be forming a C single bond C. This is how the reaction proceeds. Okay. So now let us see the detailed mechanism for this free radical polymerization. Okay. So like what is happening here? First is like generation of a free radical. That means an initiator is there that has been broken down and we got a free radical, two free radical, like as I showed earlier, O bond O. Yes, this is broken and we got an O free radical and another O free radical. Now what is happening? This initiator, this is known as initiator for us, which is represented as I. Yes, so what it will do? It will go and attack where it will be going and attacking the ethylene molecule. So now let ethylene molecule, like for example, any monomeric molecule, right? For example only I took as ethylene. Keep it aside. We'll talk about monomer. So what is the monomer here? Represented as M. Okay, so what it will be doing? The radical, whatever it is, whatever we got the radical. Sorry, there was a small mistake. Like it is not I. I is the total molecule. Okay, this complete one is I, initiator, and when it is broken, that will be represented as R. Okay, so the R radical, that will be reacting with the monomer. What it will form? It will form a free radical monomer, that is known as free radical monomer, RM1, which I denoted as RM1. Now what happened? We got a free radical, yes, monomer. Now what this monomer will do? This monomer will again go and attack another monomer. Yes, what it will be doing? We will get another monomer, RM2. This will be going and attacking another monomer. Now we will get another RM3. Like this, the chain continues. Yes, that is the step known as propagation, where it continues. The chain is moving on. As much as monomer we give to a radical, the radical keeps on attacking and elongates the chain. So the chain gets elongated. Yes, now what will happen? We have to stop at some point, right? So what it will be doing? Where we will stop? We will stop in two different ways. How it can be? That means it is a termination. Where it can be stopped? It can be either stopped by coupling. That means to any two radicals, okay, radical monomer, RMX and RMY. That is like nth step. We don't know how much it can go. So we'll go with RMX. So what is happening? The two monomer radical will be completely joined together. Yes, how it is joined? They will just couple each other. They will just join together and we'll get a coupling termination. Yes, that is known as coupling termination. Now, in another way also it can be broken. How it can be? RMX plus RMI, that is two different monomer radical, it can be broken. How? It will be like one saturated hydrocarbon and one unsaturated, like one saturated hydrocarbon and one unsaturated hydrocarbon it can give, like a monomer, okay, like polymer. What it will be? So where one is there will be C double bond C in one case, and in one case it will be a C single bond C. An alkene will be there and an alkane will be there. So that is known as disproportionation. That is known as disproportionation. So two ways it can be broken, coupling and it can be disproportionation. So once a radical is formed, like initiator, it will break down into a radical. Radical will attack with the monomer, which is known as initiation. Then the initiator will go and attack the another monomer, which the reaction continues, and somewhere like nth step, we don't know. So we'll just represent at X and Y. So it will be coupled together for the termination, which is known as coupling. When it is like disproportionated, then it is known as like disproportionation. So these are the three steps for addition polymerization mechanism by using a free radical. Okay, so this is general mechanism. Now let us take an example for polyethylene, right? So what happens here? So we knew that what is polyethylene now, or ethylene now? CH2 double bond CH2, right? So what will happen? A peroxide molecule as first. What will happen? It will, a peroxide molecule, whatever we took as an initiator, it will break down into two free radicals. So how it will be breaking down? It will have a light or heat, right? So how it is? So when a light or heat, high energy is given, R double bond, this will be broken down. Yes. So ROOR, that will give, and we will get a peroxide free radical. Now what it will do? It will have initiator. That is, this radical will go and attack the monomer molecule. How it is going and attacking? You can see from the reaction. RO is attacked with CH2 double bond CH2. So what it will do? RO CH2 CH2 radical. This dot is representing radical. Yes. So which is known as activated monomer. So free radical initiator, ethylene molecule, like which is a monomer, and we'll get an activated monomer. Now what happens? Yes, this is our second step, initiator. We got an initiator. Now what it will do? It will be moving to initiation reaction. How it will be moving? So the same thing. The monoxide, it will be moving and we get a phenyl radical. Then phenyl radical, when it is condensed or like reacted, we will get an elimination of CO2. Then initiator is this. Yes, we got. This is the reaction which I showed in the previous slide also. Yes. So the benzoyl like free radical. Then CH2, CH2. Yes. Now chain propagation, how it is moving? you can see that the initiator molecule, whatever it was there, it is again attacking a double bond, right? A monomer. So this is getting added up CH2. So this CH2 initiator is going at the last. If you see the reaction, right, it is going at the last. So like this, the reaction continues. Like propagates, it continues. Now what will happen? At last we are ending the reaction. How? By chain termination. So chain termination, how it is possible? This thing, right? Like one more of the initiator molecule, like a monomeric molecule, what it will do, it will like break. We'll just add up together, couple together, and we'll get a straight chain of polyethylene. So this is how polyethylene is formed by the polymerization reaction. Yes, so the first step is initiation for the benzoyl peroxide by an it is like a radical. It is initiating the monomer CH2 double bond CH2. The reaction is added up. Now the bond, what is happening? This monomer, radical monomer, it will be reacting with the another monomer, and the chain is getting enlarged or like elongated. So the propagation happens, and some point we have to stop the reaction. So what will happen? This two monomeric radical molecule will just couple together and we'll get a polyethylene or like a polymer, whatever is needed. So in today's class, we learned about like a mode of polymerization. What are the different types of polymerization happening, like addition and condensation polymerization. An example of addition polymer, like mechanism of addition polymerization, especially based on free radical polymerization, with an example of polyethylene mechanism, right? So I hope today's class was understood by you people all. So let us see for the next class, and I'm very thankful for getting your attention. Thank you.